Awesome. Okay, yeah, hi everyone. So welcome to our talk today. Today we want to talk about best practices and also pitfalls of instrumenting your cloud-native application. My name is Jéssica. I'm a software engineer at Red Hat. I'm also a contributor and approver for Portuguese content at the CNCF Glossary. I'm a maintainer of the Observability project, and I'm currently working with Go, and I'm also interested in distributed systems and in observability as well.
And my name is Kemal. This is how I look in the internet. I work as a software engineer for Polar Signals, if it's not obvious enough. We are building an open source project called Parka, which is an eBPF-based profiler and continuous profiling solution. If you are interested, you can check it out. I'm also a maintainer of Thanos and Prometheus client golang.
Cool. So what can you expect from our talk today? So first, we want to understand why do we need instrumentation in general. We will also talk about best practices of instrumenting your application, like using some examples, mainly using the client Golang library, but that you can also apply to other languages as well. And then see some tips, see different types of applications, so online applications, offline applications, batch jobs, and also check about SLOs and SLIs. But first let's try to understand why do you need instrumentation, right? I think, with instrumentation, it gives you insights about your application. So, for example, when you have black box monitoring, maybe you don't have so many insights as, on the other hand, if you have white box monitoring, so with instrumentation. And once you have your applications instrumented, then you make your monitoring better, right? Because then you are adding metrics to your applications, you get more insights, and as a consequence, your monitoring also gets better. And with better monitoring, then you have better user experience, and also it helps you with troubleshooting your application. So I think the short answer here is to really instrument intentionally. So think about your users, right? Let the SLOs guide your instrumentation, and think about the user experience and how can you improve that. So for those who don't know, SLOs, they mean service level objectives. And with SLOs, it has a really user-centric approach. It motivates collaboration among stakeholders. So you are not only working with people from your team, but you are also working with other teams and also with stakeholders that may use your application. And SLOs also they help with data-driven decisions. So like with SLOs, you can set up some goals for your application and understand how it will perform over time. And with that, you can also have data-driven decisions. So for example, you can define, you want that 90% of your requests, they take less than 400 milliseconds. Or let's say if you have an HTTP server, you want that 99% of it's available. So those are some examples of SLOs you can set. And once you define them, you can think about how you measure those objectives, right? And for that, we use the SLIs. So SLIs, they stand for service level indicators, and there you really measure a specific aspect of your application. Like what you measure also depends on the type of application. So for example, you can have, let's say, number of successful HTTP requests divided by the total number of requests. So that would be your success rate.
And our talk title is about cloud-native applications, and we are going to categorize these applications in the 3 types. This categorization is actually coming from Prometheus official documentations. As Bjorn put it, Holy Scripture. So these are, these are online serving systems, offline processing systems, or batch jobs. There are other classifications of the applications as well, but we wanted to stick with the Prometheus one. We will walk through some examples, and all of them based on Golang and client Golang, because it's the most common language that's used in CNCF and cloud native space, but all the tips and tricks that we give here, they apply for the other client libraries as well.
Cool, so we can then start with the online serving systems type of application. So here, the idea is that you have a client and you have a server. The client can be a user, or it can be another system, for example. And then this client makes a request to the server processes the request, and then it returns a certain response to the client. And what we recommend using for this type of system is the RED method. So RED stands for requests, errors, and duration. And then here you can create, let's say, request counters, you can create error counters. For duration, you can track your latencies using histograms or summaries. If you check the site reliability workbook from Google, I think they give a lot of nice examples on different types of SLIs and also different types of applications. So here, for example, you see that, yeah, like for the request-driven type of applications, they recommend using SLIs for availability, latency, and quality. But yeah, you can check on your own time. Yeah, like the focus of the talk today is really about showing the best practices, but we also want to list some common pitfalls. So for example, you can, yeah, like use global state everywhere. You can be inconsistent on your metric naming or on your label names. You can just like not initialize metrics, right? But we don't want to really dive so deep into it. Like you can check those two very nice talks. One of them is from Julius, like he also talks about best practice and beastly pitfalls. And also the another one is from Kemal and Bartek, which I think is also speaking at PromCon tomorrow. Yeah, about testing your observability in general, and then there they also mention some pitfalls. Cool, so I think we can then dive into some examples. As we mentioned, like we defined what an online serving system is, so I think now we can really try to understand how this applies in practice with an HTTP example. So again, all of this is using the client Golang library. And as our first tip, we want to say, yeah, avoid global registry. So what do we mean by that? Like here you have, for example, a HTTP server. Like we can start with some imports, like we import the Prometheus library package, the collectors, the PromHTTP, all from the client Golang. And then we create our non-global registry. What is nice about it is that we can add our metrics like little by little, and we are not like exposing more metrics than necessary. So yeah, like we register our collectors. So in our case, we want to use the Go collector and the process collector. And then we can expose our /metrics endpoint. And then here we pass this custom registry that we just created. If we go to the /metrics endpoint, you see all of those metrics. So those are the ones that we just added with the collectors. So you have things like number of OS threads created, virtual memory size, and yeah, also the PromHTTP metric handlers error metric. But yeah, like the idea here is really add your custom collectors, add metrics as you see fit, custom registry, sorry, add your collectors, and then there you are exposing just the metrics that you really need. Cool, so our second tip is to don't repeat yourself and use middlewares. So what do we mean by that? Like with middlewares, you can make sure that you can wrap your handlers, so like your HTTP handler, for example, and then there you can add to your middleware the metrics that you want to expose. So with this, you achieve also auto-instrumentation, right? So let's see an example. So here, for example, we create a package, HTTP middleware. We define our middleware interface. We have this wrap handler function that then receives the handler name and also an HTTP handler. And then we return the HTTP handler function. And then we can create a struct. So like we have our middleware struct with some buckets as a field, so a list of buckets, our registry, and then we create a new function. This function will return the middleware interface. We check, okay, like if we don't have buckets, we create ourselves using the exponential buckets function, or you could also use the linear buckets, for example, from Prometheus. And then we return our middleware struct, a pointer to the middleware struct with the buckets and the registry. But to make this to actually work, then you need to create the wrap handler function, right? So then we are implementing our middleware interface. And then here we create a registry, and we wrap this registry with a specific label, which is this handler label, and that we use the handler name. So that's useful, like if you have different handlers and if you want to kind of identify them in your metrics. And yeah, then now we can start adding the metrics we want, right? That we want to use in our auto instrumentation. So we have, for example, a counter, so request total. We have a request duration. Can also check the request size, the response size as well. And yeah, after adding all of that, we can start then wrapping those metrics using this instrument handler counter function, for example, for the request total. For the request duration, we use another function that's called instrument handler duration. So we do all of that, and then we return the handler function. Like we call the serve HTTP function from the handler. We return this, right? So we have now our handler function. And then when we go to our main code, then we can finally wrap our metric. In our case here is the metrics handler, but you could also wrap any other handlers you have in your code. We wrap this handler with our wrap handler function, and then we use our custom registry as well. Cool. Also, if you want to check gRPC examples, so all of this was for HTTP, right? If you want to check gRPC examples, you can go to this repo. I think they also have some nice examples there. And yeah, like our third tip is to use exemplars and correlate. So exemplars, they are a really nice way to then correlate your metrics with traces, for example. With exemplars, you kind of add this, you will see in the examples that we show here, but you kind of add this extra label with a trace ID, let's say, if you have a tracing system. And then with that, you can correlate this metric with all the observability data. But yeah, like if you want to check more about exemplars, there is a very nice talk from Ian. He did, I think, was in Prometheus Day this year in KubeCon Europe. So yeah, it's also a nice way to dive into that. But as a quick example, we can create, let's say, a histogram, right? So to track our request durations. Yeah, like here we define the buckets as well with exponential buckets. We make sure that we register this metric, so using our custom registry again, but now registering besides all the collectors we added, we also add our request duration metric. And then for this example, let's then kind of record a fictional latency. And I think the important bit here is really that you use this function called observe with exemplar. That's available in the client golang library. And then here, in our example, we are passing a dummy ID, right? So we are kind of just generating a random integer. And then we pass this to the observe with exemplar. So now this latency that we recorded will have the exemplar attached to it. So very important is to also make sure you use the option enable open metrics. So this you pass in your handler opt from the Prometheus TTP package in your handler, and then you set this to true. And in your Prometheus configuration, you should use the enable feature flag set to exemplar storage. So then you make sure that you can query those exemplars. And just, like again, for the exemplars, they just support, as far as I know, for now, just the open metrics format. So that's why we need to set this option there. Cool, so now if we query again our /metrics endpoint, we need to make sure that we pass the header, right, like the application /open metrics text header. And then here we can see very nicely that it added a dummy ID, which in our example is random, is generated, but in your case you can also add your own trace ID to it. So yeah, it's very nice to be able to use that, and I think it's nice to be able to correlate your metrics also with all the observability data.
All right. We've seen like request-driven applications, but it's not the only type of applications out there. Yes, like probably overwhelmingly all the systems we have either HTTP-based or gRPC-based, and they're online system that actually consumes requests. So in this example, we are going to talk about some offline processing systems. These could be some data pipelines, ETL systems, where you don't need to respond to the requester immediately. So in that sense, they are like asynchronous and event-based. So while giving this example, I also want to promote a new pattern we've been working on, like client golang for the past few years. So in this example, you see that rather than using a global state, we create a struct, and in that struct, we collect all the metrics that we have. And then we have this constructor that actually consumes a registry, and using that registry, we just like specifically initialize those metrics for that registry. There are several use cases with this pattern, which we'll see in different parts of the systems. But like to just foreshadow it, what you can do with this registry, for each subsystem, you can actually wrap that registry with either a prefix or a label so that you can reuse the same metric structure and other metrics throughout your system. So what else we do to just like demonstrate that? We have Prometheus wrap register with helper function from client golang, and this just represents a stage, and it spawns a Go routine to just like mimic a pipeline stage. And it's kind of dynamic because you inject a name, and we put that name as a label and wrap the registry and use the same metrics for this stage. So far it's good, but if you were to try this code with a global registry and reuse the same metrics over and over again, probably you would get a panic because like you cannot re-register metrics more than once. But since we were wrapping the registry, we can use this pattern and have different metrics without redeclaring them. We can reuse those metrics. So on this topic, like more best practices, we need to talk about some pitfalls of the histograms, right? In the histograms we talk in here, these are the conventional histograms, and one of the biggest problems with the conventional histograms, by default, if you don't specify any bucket layout, you get like 12 buckets, and each bucket is a time series. And then you just like add some labels on that. Those labels tend to be multiplicative, and it is a cardinality bomb at the end. And on top of that, you need to know about distributions. But how to solve this? I guess now we have the solution, so we just stay calm and just migrate to the native histograms so that all the problems that we have with the old histograms goes away. So you already heard about these with these talks. For the ones that in the in the venue, but for the recording, you can check out this talks by Björn and Ganesh. They kind of binds together. With the naming, I guess there were a lot of names around, native, sparse, exponential. I guess right now we call them native histograms. So we already seen similar things, but like this is how you enable from the Prometheus side. You need to pass that flag. From the client Golang side, you need to pass an histogram option and specify that factor. We've seen that Prometheus is released on the stage, and this morning we also released a client Golang, so you can start experimenting with that. So there are another type of applications that we can also see. These are like ephemeral workloads, like this background batch processes that where you, for example, migrate, like get a dump of your database and have backups or functions, the function as a service workloads. So for that, like we have the same pattern, like more or less the same metrics actually, but the only difference I guess we want to demonstrate here is, again, we are using the metrics and we are doing some work and consuming those metrics and increasing, but the crucial part is actually we need to push these metrics somewhere, because since these workloads are ephemeral, Prometheus cannot scrape these jobs because they are not there when this happens. So for that, we have APIs in the client code, and you can push these metrics to a push gateway, and then your Prometheus can scrape those push gateways. So it's like, it's not always super intuitive to understand what is the difference between offline processing and a bad job, but like in the documentation, I think we are doing a really good job. So I'm putting this, especially this second link for the documentation, so that when you need to reach out some tool like that, you can check out. So it's like strictly, to give a summary, it's not like a workload like stats.d so that you can push metrics, so it's not converting your Prometheus a push-based system, but rather to just get a snapshot of your last workload running. If you need like further needs and aggregate metrics, maybe you have a function as a service thing that you would like to collect metrics on, you can use this project. I haven't actually used any function as a service thing, but it's like, this is the recommended project for Prometheus docs. So what else? Like when we talk about best practices, definitely the naming is important. These are, most of these rules are not enforced, and I don't want to delve into them. There are a lot of talks out there. You can check them out. The one thing I would like to emphasize is the total suffix. It's not an optional or a convention anymore for client Golang, for example, because we are planning to migrate to the open metrics at some point, and at least if you are using counters, please make sure that you are using a total suffix. Not to just, yes, we just skip the naming conventions because we have static analysis, some static analysis tools to catch like any super obvious things that you can catch up with your metrics. One of them is PromTool. It's already in the Prometheus main repository. It's a separate binary. You can use it and target it to your metrics endpoint, and it can immediately check your any problems with your metrics and naming or labels. Then it can report you. You can integrate this to your CI, and you can check out if something is going wrong. In a similar project, we have a linter now from the community. What is the difference is this is a static analyzer, so it just like parses your code base and checks your instrumentation code, and if it can catch anything out of ordinary, it can report. So with that, maybe the most practical one is actually testing your instrumentation as well. Like instrumentation is code, and you can test everything, and we actually showed some pitfalls, like not initializing your metrics or catching for cardinality bombs. For anything, you can actually write unit tests for instrumentation, or you can use your unit instrumentation code metrics to actually even check the behavior of your program. For that, in client Golang and the other libraries, we expose some helper function for tests. That's the emphasis in the Prometheus test util from the client Golang. And as you can see, you can actually check against metrics. You can check the number of the labels. You can actually weight some metric to actually increment it to the certain value, and you can stop your test until that point. This is a very useful pattern. At least in Thanos, I think we abuse this system, and we test everything based on, most of the things based on our metrics.
Oh, yeah, so I think... Can you hear us too? No, yeah, we can. It's a bit confusing here. Cool, so I think after all of this, what we really want to stick with you today is, yeah, like first, make sure you use your metrics with purpose. So instrument intentionally, let the SLOs guide your instrumentation, think about the user. And yeah, like conventions are here to help. Like there's a lot of best practices around, and I think there's also room to improve and to create even more. And yeah, you're always welcome to contribute back. So that's our client Golang repo. Yeah, feel free to open issues, improve documentation, anything, add more examples. So anything, it's welcome.
Not just client Golang, any client libraries, please.
All client libraries.
And the official documentation.
Yeah, but yeah, thank you so much. That's what we want to show today. And here's a list of resources. So like, yeah, if you want to take a picture and take a look at your own time, yeah, I think at least for us, it was very useful. But yeah, thank you.
Thank you.
Alrighty, thank you. We're a little bit over time, but are there like 1 or 2 questions, max? I don't see any hands going up. I think everyone's hungry. So let's have lunch.